We're going to wrap up this chapter by looking at solving formulas, or not really solving a formula, I guess it's like rearranging a formula to kind of solve for a different variable, I guess. So a couple of things just to be aware of is that if we see a letter and I see its lowercase and capital of the same letter appearing in an equation, those are different variables. You know, little w and capital W, those are different variables. It's like having an x and a y. And also subscripts are used to do the same thing, like v and v naught are completely different variables. It's like having an x and a y. So be aware of that as you're working through these. And this is just going to kind of give us practice in being a little bit nimble with these formulas, and being able to kind of rearrange things is actually a good skill to have. So here's a famous formula, E equals mc squared. If I want to solve this for m, then I want to get m by itself, and I can see that m is being multiplied by c squared, so I will just divide both sides by c squared. And then we have e divided by c squared, that's equal to m, and there's the result. And there we did, we solved it for m. In this next one, here's a formula that says it gives us the velocity of an object that has an acceleration equal to a and an initial velocity of 0 at time t. And we want to solve this for t. So, you know, I want to be aware, I want to keep in mind like what my goal is, kind of keep my eye on the ball. I want to get t equals at the end of all this. So I'm going to isolate that t term first, and the way I do that is just by subtracting v naught. On the left side, when I subtract v naught, I get v minus v naught. Those are not like terms. This is equal to a times t. And now if I want to get t by itself, t is being multiplied by a, so I'm going to divide both sides by a. And that gives us t equals v minus v naught divided by a. Alright, next we want to solve this formula for capital P, or I guess there's not a lowercase p, so we just want to solve this for P. I'll note that P is inside parentheses, so I'm going to have to do something to get it out of the parentheses. The other thing I noticed though is that there's this equation has a fraction. So I'm going to start, so let me just write this out again. I'm going to start by getting rid of the fractions. I'm going to multiply both sides by 8. And we get 8w equals, over here the 8's cancel, L times W, L plus 2P. And we have a capital W and a little w. I'm going to keep that in mind as we go through this. Now I want to solve for P, which means I got to get it out of those parentheses, and the way we get something out of parentheses is I use the distributive property. So I'm going to distribute this L through those parentheses. So I get little w L squared plus 2LP. Now that that's out of parentheses, I can isolate the term that has the p. I'm going to do that by subtracting little w L squared from both sides. So on the left side we get 8w, 8 big W minus little w L squared. On the right side we have 2LP. Now p is being multiplied by 2L. I can divide both sides by 2L. I can take care of both of those factors at the same time. So once we do that, on the left side the 2L's cancel, or sorry, I guess that's the right side here. And then we have P equals that fraction 8 times big W minus little w L squared all over 2L. And I'm going to leave it like that.
Yeah, so like...
Alright, in this last example, we're going to solve this one for big M. We'll note that this also is a fraction, and big M is in parentheses. So I'm going to start out kind of the same way. We have a little m and a big M. I'm going to start out kind of the same way, and I'm going to clear the denominator. Now, we've mostly just been working with fractions where the denominator is a constant, but the principle is the same, even if I have a variable down there. If I want to clear that denominator, I'm going to multiply both sides by little m. So I have little m, little v equals, on this side those m's cancel, so I got big V, little m plus big M. I want to solve for big M. I need to get it out of those parentheses. So I'm going to distribute that V on the right side. So big V times little m plus big V times big M. And now I will subtract the big V little m from both sides, because now I can get that big M term by itself. So now I have little m, little v, minus big V, little m, equals big V, big M. And the only thing left to do to get m by itself is to divide by big V. So I'm going to do that on both sides. That gets us the result. Big M equals little m, little v, minus big V, little m, all over big V.